Question 4, a large jug contains 2 kilograms of milk, is placed in a refrigerator. The milk cools from 18 to 3 degrees Celsius over a time period of 100 minutes. The specific heat capacity of the milk is 3,800 joules per kilogram per Kelvin. Calculate the thermal energy removed from the milk as it cools. So here we're going to use E equal to mc delta theta. Straightforward. 2 kilograms. The specific heat capacity is 3,800, and the change in temperature is from 18 to 3, so 18 minus 3, so obviously 15. We do the calculation then. That's 114,000 joules. The rate at which thermal energy is removed from the milk. So we know power is equal to the work done or the energy transferred over the time. We've got 114,000, and the time is 100 minutes, so that's 100 lots of 60 seconds. Which gives us a power or a rate of thermal energy transfer of 19 joules per second, or 19 watts. And part C says another container of milk is placed in a freezer and cooled from 18 to minus 18. Assume that thermal energy is removed at a constant rate and that the freezing point of milk is 0 degrees Celsius. The specific heat capacity of milk below 0 is significantly less than its value above 0. So just highlight that because that's going to be important. On the axis below, that bit's important too. On the axis below, sketch a graph to show the variation with time of the temperature of the milk over the range 18 to minus 18. Numbers are not required on the axis, but you should annotate the key points. So because it says we want the first bit, the cooling, it says it's going to happen at a constant rate, so we should expect a straight line from 18 down to 0. We might want to annotate this is the milk, which is still a liquid, cooling at constant rate. Then when it gets to 0, we're going to need to transfer some energy from it for it to change state. So we're going to have a horizontal line. Let's choose a different color. Oops. So this is the milk changing state, liquid to solid. Can't write solid. And then the second part, so the specific heat capacity is lower. So when we remove the same amount of energy, we should expect a bigger temperature change. So compared to our first gradient, we should expect the thing to cool more quickly now because it takes less energy to change its temperature. I'm going to put in a steeper line here. Let's change the thickness so it matches the others. Steeper line here, and this is the solid milk being cooled from 0 degrees C to minus 18 degrees C.